Hi. Since CAT is 1 month away, we're going to try and see whether we can help you in the logic and DI set and see that whether you can do them quickly by maybe some shortcuts or some tricks which will help you to do them faster. So let's look at a particular set which we are going to talk about today. Before we do that, I hope everybody has downloaded the set. So hence, if you haven't, please pause the video and do so. Okay. Let's just quickly read through the set, trying to understand what we are talking about. 3 soccer players, Lampard, Messi and Tevez, are playing a game of penalty shootout. In this, every player is allowed to take a shot at the goal 4 times. So one player, when he starts taking a shot, he will take the shot 4 times. If he scores a goal, he gets 10 points. If he misses the goal, others are awarded 5 points each. Now that's a very important information, that if he misses, the other 2 players in this case will get 5 points each. Each player successively takes 4 shots at the goal, followed by the next player, not necessarily in the given order. That's always a disclaimer in all kind of DI sets. Not respectively, not in the same order, being very important words. When the 3 of them have finished one such round, which is 12 shots, the process is repeated in the same order as before. The first player to reach 300 points wins the game, and the game stops once this is achieved. So now let's look at what we are talking about. We are saying that once a player starts shooting, he's going to kick the ball or shoot the goal for 4 times. And once he's done with that, the next player will come on and so on. That whole thing will be 12 shots, will be one such cycle. And then a new cycle will start. The final scores were, what I would have done in such a set was, maybe made a table of this sort and kept a table so that I can now start putting in all the information what I need. Okay, the final score was Lampard has scored 300 points. Messi has scored 265 points and Tevez has scored 215 points. The other information given in the set is that the total number of shots taken was 78. The total number of shots taken was 78, out of which 43 was scored off and 35 were missed. Okay, now once you realize that 78 shots have been taken, which means 6 rounds of 12 shots have definitely been completed. 6 rounds of 12 shots have definitely been completed, which will mean 72 shots. That means the 7th round has started and the first player has taken his 4 shots and the second player has taken 2 shots, and at that time the game has ended. Now a very big mistake or a very common mistake which we say in this set is, everybody assumes that the person who shot the last kick has won, and therefore everybody assumes that Lampard, who is the winner in this case, was the one who has taken those 2 shots, which is not necessarily true, because it could have happened that Tevez was shooting and he missed and Lampard got 5 points, because of it Lampard won. So please remember, don't make such assumptions. This is a very common assumption. So now we are saying, since 78 shots have been taken, the only way this could have happened is, one player has taken 28 shots, second player has taken 26 shots, and the third player has taken 24 shots. So 28, 26 and 24 being the key numbers in this set, that 28 shots have been taken by player 1, player 2 and player 3, not necessarily in the same order. This could have been taken by anybody. Okay, since we have already seen that the total number of shots taken by the players can be only 28, 26 and 24, which all 3 are even numbers, which means the total shots taken by Lampard has to be an even number, total shots taken by Messi has to be an even number, and a total shots taken by Tevez also have to be an even number. Now with simple logic of maths, we know that if I want the sum to be even, both the numbers have to be either odd or both have to be even, which means the number of goals scored by Lampard and the number of goals missed by Lampard will have to be odd or even, and so on for all the 3 players. Okay, now one very good technique which we normally believe in is, in DI or in logic, is always read the questions before you really start analyzing the set. What information you want to put, what can I plug in, can I make equations over here? I would prefer that you actually read the question and see what is asked. So it's always easier to then interpret the set accordingly. So for this, in this set particularly, if you look at question number 1 and 4, they go completely hand in hand. how many goals did Lampard score and how many goals did Lampard miss. Now if you look at that information, how many goals did Lampard score and how many goals did Lampard miss. So we're looking to solve these two boxes or try and get values at these two boxes. Now as we know, either both of them are going to be odd or both of them are going to be even. Hence looking at options is going to make the set very easy. So for example, as we have seen that the total number of shots taken is maximum 28. Option number 1 and 2 are completely ruled out. If the maximum number of shots Lampard has taken is 28, how can he miss 42? Or how can he miss 34? That's not possible. So hence we are talking only about 17, 23 and 20. Now let's also look little bit slightly more detailed. Now if you look at this, Messi and Tevez both have scored 265 and 215 points respectively, which means if I say Messi has scored 265 points and Tevez also has scored 215 points, that means the number of goals missed by Lampard has to be an odd number. Why is this important? This is odd. The number of goals missed by Lampard has to be an odd number. Why does this have to be odd? Because if this is odd, only then can their bonus points be a multiple of 5 which ends in 5, and hence their total score will be an odd number. So now once we've realized that the total number of goals missed by Lampard is odd, the total number of goals scored by him is also odd. Fine, is that fine? I'll just repeat this part so it gets slightly more clear, that because the total score which Messi and Tevez has is an odd number, therefore the total number of goals missed by Lampard has to be an odd number, because the number of goals he misses will give 5 bonus points to these two, and hence the total number of goals missed by Lampard has to be an odd number. And then from simple mathematics we know that the total number of goals scored by him also has to be an odd number. Now, so based on that, if I am looking at the options, as I said, option 1 and 2 are completely ruled out. Now option number 5 also has been ruled out, because option number 5 is 20 and we are talking about an odd number. So option 5 is also ruled out. So we are now talking about 17 and 23. So if I now look at 23 as an option, let's assume he has missed 23 goals or 23 shots, which means based on this he would have scored, or if he has scored 23, I think I made a mistake there. Let's assume that he has scored 23 goals, which means he would have to miss 5, 3 or 1 goal. Now question number 4 does not have those options at all, which means 23 is also ruled out. So we've actually got an answer over here that the total number of goals scored by Lampard is 17. Now we are very sure of this answer because we have eliminated all the other options. Now once we have eliminated all the options, 17 becomes a definite score. Okay, since now we have already established that the number of goals scored by Lampard is 17. Now for these 17 goals, at the rate of 10 points per goal, he has already achieved 170 points. So now which means to reach a total of 300, he has to achieve 130 more points by the bonus or via the means of bonus points. Now these bonus points will come to him when the others will miss their goals. So now to achieve 130 points, the others together, and that is why I am just erasing this, the others together will have to miss 26 goals. So 26 goals missed by them will give you 26 paisa 130 for Lampard. So Lampard's score will come 170 plus 130, which is 300. So is that fine? Now once the others have missed 26 goals out of a total of 35 missed goals, which means we know that Lampard has missed 9 goals. So now we have achieved answer to question number 1 as well as question number 4, and that is why this was very important to take both these questions hand in hand. Once you knew that, you could have easily checked via options also, and this comes out very easily. So once Lampard has scored 17 goals, the others have missed 26, due to which Lampard has missed 9 goals, and now we have checked that, hence the total score which Lampard gets is 300. Okay, let's start solving question number 2 and 3. Question number 2 is asking us to check how many goals did Messi miss. So we are talking about this value, how many goals did Messi miss, and how many goals did Tevez score is question number 3. So these are the two values I am looking for. Now if I look at the total score which Tevez has, 215 is an odd number. For Tevez to score 215, which is an odd number, the total number of goals missed by Lampard plus Messi has to be an odd number. Only then can this answer end in 5. If these two were an odd number, only then it is possible. So now, which means this has to be an even number. As we know, if this is even, this will also have to be even. This is even, so this will also have to be even because the total is 26. And since this is even, this will also have to be even. So we have established that both the answers which we are looking for, question number 2 and 3, have to be even numbers. Hence via option I have eliminated for question 2, 4th and 5th option, and for question 3 I have eliminated 2nd and 4th option. So I have eliminated all the even options. Now let's look at it. If I look at any one particular option, how many goals did Messi miss? So if I look at the even option, say 6. Now is it possible that Messi could have missed 6 goals? So for him to miss 6 goals, we are saying that this guy, that is Tevez, has to miss 20 goals. Now if Messi has missed 6 goals, what is the number of goals he could have scored? We've already used up 26 out of these 3. So 26 is gone. We are left with only 28 or 24. So now if he has missed 6 goals, the other 2 together have missed how many goals? 35 minus 6, which is 29. For those 29 goals, Messi would have got 29 Faiza, which is how many points? 29 Faiza is 145. And 145 bonus points Messi would have got. Hence, to score 265 total points, he would have to have 120 of his own points, which will be 12 goals. 12 plus 6 is 18. Does not satisfy any of these values. So I have purposely used an option which is not working for you to understand how to eliminate options. So now if I look at the next option, that is 10. Now if Messi has missed 10 goals, which means Tevez has missed 16 goals. Now if Tevez has missed 16 goals, 16 plus 9, 25 goals have been missed by Tevez and Lampard. And for those 25 goals, 25 Faiza, 125 points, bonus points are got by Messi. Now to reach 265, he'll have to make 140 of his own goals. So 140 will be 14 goals scored, 140 points, so 14 goals scored. 14 plus 10, 24 is a possible option. We are not saying that it is a definite option, but it's a possible option. Now if this was 14, I can easily get all the other values. 17 plus 14 is 31. 43 minus 31 will give you how much? 12. Now if this is 12, this is 16. Does it give me the right total for Tevez? So now 12 will give me 120 points for Tevez, and 19 goals missed by the other 2 will give me 19 Faiza, 95. So 120 plus 95 gives me 215. Which means there is no loophole. 12 plus 16 is also satisfying 28. So all the things have been checked and we've actually got all the answers. So we've got an answer for question number 2. Question number 2 would be second option. How many goals did Messi miss? How many goals did Tevez score would be 12, which would be option number 1. So we have already got the answer for second and third question. Now we could actually see that we've got a lot more data than may be required also, and if the questions had been framed in any other way, you could have still gone by the same method and got answers to other questions too. Okay, now let's try and look at what are the different learnings we had from this set, which we can now maybe implement in other DI and logic sets also. So for example, if I look at what we did in this set, first thing, we had an easy format. What do I mean by easy format? Now the set was given to you in the form of a case. You also have to remember now CAT is online. So the set will be given to you on a computer screen. You're not going to be able to maybe underline something. Maybe you can still mark, but you're not going to be able to underline things and all. So it's always going to be easy if you can take all the information and put it in some format which is easy for you to refer to. So for example, in this case the table made the set maybe very comfortable for us. We did not have to keep referring to information again and again. For example, Lampard at 300 points, Messi at 265 points, Tevez at 215 points, were information which were very clear in the table, and I did not have to keep referring to them again and again. So we should always try and see whether we can put the data given to you in an easy format. That format could be a table, it could be just maybe noting down information on a piece of paper. You also have to remember now in CAT you have enough rough work available, so that's never going to be a big issue. You can draw the whole table actually, maybe not like 5 years down the line or 6 years down the line when there was not enough space available, and always the constraint used to be okay, DI ke andar how will I actually put the information. So now there is enough space available, you can draw a table easily, maybe put it down in a row or whatever information is given. So according to me, always put the data down in an easy format. That's your first important point. The second point, which we at CREDence really strongly believe in, this goes for every DI set, every logic set, and maybe I can go to the extent and say even for RCs and verbal, is that always read questions before solving. When I say read questions before solving is, before you start analyzing the set, you're going to decide, should I do this set by equation, should I do this by whatever method, I'm going to put variables x, y, z, whatever. But before that you always read questions. What is asked? One advantage of that is that you can always see that once you're very clear what you are searching for. For example, over the last few years we've got to know that in CAT what happens is that there's a lot of information overload, and maybe the questions actually don't require all the data. So you are actually maybe wasting a lot of time analyzing the data, and finally the questions don't ask you all the data or don't need all the data. So you're wasting a lot of time. So always read questions before solving. Once you've pointed this out that read questions before solving, so you have a very clear idea, also it will help you to decide whether I actually attempt this set or not. If there are too many cannot be determined, too many maximum, minimum values and all that, you can be slightly aware that these is going to be maybe slightly more difficult set with a lot more possibilities. And hence, reading questions before solving or before analyzing always. The next 2 points which we look at are constraints and options. Now when we talk about constraints and options, we have to try and identify what are the constraints in that particular set, and how will they help me to use the options more efficiently. So for example, if I talk about this set, for me the constraints in this set were that the total number of shots taken by the 3 players were 28, 26 and 24, which all 3 were even numbers. Now because of this, I have realized that the total number of goals missed plus the total number of goals scored had to be an even number. Now the total number of goals missed plus total number of goals scored had to be an even number, which means that either both had to be odd or both have to be even. The other constraint which I had was that the scores of the 2 other players, that is Messi and Tevez, were 265 and 215, which were both odd numbers, due to which I had also achieved or established in the sum that Lampard had missed 9 goals or had missed an odd number of goals. So these all constraints help us to easily use the options in a much more efficient way, and hence options and constraints in this particular set we saw made a lot of sense. Now not that it made sense only in this set, in general also in DI and logic, if you are aware of your options and your constraints, you can easily always limit yourself to a particular level, that your data is not going to go beyond a particular level, so it's easier to solve. Also you can then figure out through options whether is the set solvable or not. So for example, is there too much cannot be determined, or is there a lot of data which is not needed? All those things can be used.
Hi, I'm Bhavin. We run CREDence Academy in Mumbai, and we are mainly into entrance examination coaching for MBA. Let's now look at a typical calculation DI set. Very basic line graph, values given at each juncture. If you have not downloaded the file for reference as yet, please pause the video and do so. Alright, so if you've read the question in the file, it says the following line graph gives percentage increase in number of electronic gadgets sold from the previous year. So if I look at this graph, the value for the year 1996 is listed as 40 and the value for the year 1997 is listed as 50. So with the given one line information that we have for this graph, what can we make of these two values, 40 and 50? Is it that there is a base of 40 in the year 1996 and as against that it has increased to 50? If that is the case, it would mean that there is a base of 65 in the year 1998 and that value has now decreased to 60 in the year 1999. Or is it that in the year 1996 the value for that year is 40% more than the value of the previous year, which is 1995? Likewise, in the year 1997 it is 50% more than the value given for the year 1996. If you read that line again, it says graph gives percentage increase in the number of gadgets sold. So which means every value on the graph is actually a percentage increase. Now when we look at normal line graphs, we always feel that a downward slope means a decrease, as in this case from the year 98 to 99 and from the year 2000 to 2001. But what we would miss in such a graph, such a basic looking graph, is actually each of these values are percentage increases. So in technical terminology we would say this is not a continuous graph because the values are not increasing from here and decreasing. It is just some data represented in the form of graph which actually means each of these are percentage increases, and because the year 1999 has an increase of 60% over 1998 as against the year 1998 has a 65% increase over 1997, which is why the comparison shows a down. Since we have already understood what data is given in this graph and what it actually means, let's now have a look at the questions. If you have not already downloaded the file for reference, please pause this video and do so soon. Okay. If you refer to that file and have a look at the three questions, the first and the second question start with the word if, and the third question asks you what was the ratio between two particular numbers. Now, typically in DI and logic, we always suggest this to students that you should read the questions before analyzing any data given to you or before starting anything in your solution. Reason being that if questions are like the first two ones here that start with an if, then all the work that you've done here, understanding the data and then making some notes and writing some numbers and figures, all of it may not be needed for that question because probably that question is going to throw a condition at you and you have to make your calculation only based on that condition. Also, reading the questions will minimize the possibilities that you have to work with and probably narrow it down to one or two cases that you have to deal with. So, if we look at the questions closely now, the question, first question says, if in 1999, 264 crore gadgets were sold, how many gadgets were sold in 1997? Also, the options don't have a cannot be determined, which means a clear-cut relationship can be established. Now, we know that in the year 1999, there is a 60% increase over the value in the year 1998, and in the year 1998, whatever is the value, is a 65% increase over the value in 1997. Since the question asks us to find out the value in 1997 as compared to 1999, we only need to make our solution for this period, which is 97 to 99. The value for 99 is given as 264 crores. Like I said, which is 60% more than the value of 1998. So I can write it is 160% of the value of 1998. Now, when we do calculation based DI, instead of working with bigger numbers, generally percentages can be dealt with very easily if we know our reciprocals well. For example, 20% is 1/5 of something. if I want to find out 60%, that is 3 times of 20%, which means it is 3/5 of something. So if you want to increase a number by 3/5 of itself, you would ideally do 1 plus 3/5 of 1, which is 8 by 5. So I am better off just writing that the value for 99, which is 264 crore, is 8/5 of the value of 1998. And likewise, the value for 1998 is 65% more. Coming back to reciprocals, 5% is 1/20th of something. Since 65 is 5 into 13, it is 13/20th of something. If you want to increase a number by 13/20th of itself, you are typically going to do 1 plus 13 by 20, which gives you 33 by 20 of that number. So I can just say the value for 1998 is 33 by 20 of the value of 1997. So combining these two, I can now say that the value for 1999, which is 264 crore, is 8 by 5 of the value of 1998, which in turn is 33 by 20 of the value of 1997. So now what we have eliminated by doing this is that first of all, in this equation you don't see the value for 1998 anywhere. We did not even calculate the value of 1998 as it was not asked in the question. The whole idea of using reciprocals or ratios is to build a continuous relation between the start point and the end point, so that all the intermediate values, which in this case being the value for 1998, which are not required, need not be solved, and in turn that reduces the solution time in the question. So 264 crore is 8 by 5 into 33 by 20 of this value. So you can just directly solve and get the value for 1997 is 264 crore into 5 by 8 into 20 by 33. And if you now cancel, you get 4 2s are, 4 5s are, you get 11 3s are, and you get 88 3s are, 11 1s are, 8 11s are, and that gives you 8 into 5 upon 2. So that's 8 into 25 upon 2, which gives you 100 crore. So the value for 1997 in terms of number of gadgets sold is 100 crore. If we proceed to question number 2 in this set, similar nature. If in 2000 the number of gadgets sold was 81 crore, how many gadgets were sold in 1999? Well, here 2000 and 1999 are given as reference points, so we would anyways not have an intermediate value, but since we've already established the importance of reciprocals and just using ratios to quickly arrive at the value, we'll see how this question can be solved with the given values. The number of gadgets was 81 crores in the year 2000. So the value for 2000, which is 81 crore, is, now having understood the graph, we know this is 80%. So it is 80% more than the value for 1999. Like I said earlier, 20% is 1/5 of something, hence 80% will be 4/5. And if you want to increase something by 4/5, you would typically do 1 plus 4/5, which is 9 by 5. So we can say 81 crore is 9 by 5 of the value of 1999. And likewise, you can just solve directly. Value for 1999 is 81 crore into 5 by 9. That gives us 45 crore, which happens to be option number 2. The third question says, what was the ratio between the number of gadgets sold in the year 2000 and 2001? So we need to compare the value of 2000 with 2001. Now, we know that there is a 70% increase in 2001 as compared to the value of 2000. So, ideally we should first have a look at the options and see in which case the first part of the options is less than the second part of the options. Because out of the given options, if only one option is in such a format, even the solution to this question is not required. Now the first option is 9:8, in which case the first part is more. So they are saying that the value for 2000 is more than 2001, which is not possible because in 2001 there is an increase over the value in 2000. Similarly, option 2 is 18:17. So first part is more than the second part, eliminated. Also in option 3 it is 8:7. For the same reason I would eliminate it. First part is more than the second part. Option 4 is indeterminate. Now since in the previous two questions we have seen you can easily draw a relation between any 2 years, whatever be the gap between them, indeterminate as an option in this question does not make sense. So hence without solving anything in this question the answer is none of these, because you are going to get a value where in this ratio of A is to B, A has to be less than B. Let's do a quick roundup of what important things we realized in solving this set of graph, and what are the important pointers that you should generally look at in such a set of DI. First and foremost, even though the question has just one line of general data given, following line graph gives percentage increase in number of electronic gadgets sold from the previous year, and there is nothing beyond that line except for this graph. What is important is to catch on to the words percentage increase. Now, in the beginning of this video, I explained that one of the possibilities could have been that you do a relationship between 40, 50, 65, 60, 80, 70. Think of it as a continuous graph. This is generally what a lot of students think and end up solving the whole set based on this comparison, assuming it to be a continuous graph. More often than not, in such sets, the options, the first or the second option in every question will be given in such a way that there will be correct answers for the wrong understanding of the graph. So to avoid that, it is always very, very important to, one, obviously read the general data given to you, but two, to also read the questions before you start any solutions so that you understand the relationship in the values in the given data, and probably also give yourself a higher chance of realizing that it may not be a continuous graph but just values represented as a relation on a line graph. If you have read the questions in detail, particularly in this set, you would realize that they have asked you for comparisons between values for 2 years. They have also given you value for a year and based on that asked you to find out for value for another year. Couple that with reading that this is a percentage increase graph would probably increase your chances of understanding that these are all increases and a 65 to 60 or an 80 to 70 may not mean a decrease. Secondly, in calculation based DI sets, it is very, very important to know your reciprocals for percentages. Most calculation based DI sets, whether it's a line graph like this or a bar graph or a pie chart, generally revolve around percentages. And that's been a trend over the last many years in CAT. There are a lot of calculation based DI sets based on percentages. So it is handy in that case to know reciprocals like probably 1 by 17 which is 5.88% or 1 by 13 which is 7.69%. Such reciprocals help a lot in approximating the data, examples of which we saw in the calculation that we did. We didn't work with a lot of big numbers. Most of the things got cancelled because of the ratio. And that's how we eventually ended up solving very less but getting all the answers accurately. In some cases you may also just need approximate answers because the options are very far away from each other. In that case also reciprocals or ratios help a great deal.